This is Bob Capetta, and this is a lesson on completing the square when the equation is of the form ax squared plus bx plus c equals 0. What makes this challenging is when a is something other than 1. So here's our first example, 2x squared plus 6x minus 1 equals 0. So the leading coefficient, the coefficient on the x squared term is 2. I can't work with that. We have to eliminate that coefficient. We will do that by dividing everything by that 2. So 2x squared divided by 2, 6x divided by 2, minus 1 divided by 2 equals 0 divided by 2. This will force the leading coefficient to be 1. However, you will also notice that it often gives us fractions, which makes things a little bit more challenging. So at this point, we are going to leave the x's on the left side and move the numbers to the right side. So let's add 1/2 to both sides so that we get x squared plus 3x equals 1/2. This is the form that we need. Leading coefficient of 1, so a 1 on the x squared, the x terms on the left, the number term on the right. And then to complete this square, we've got to add some number to both sides. Add some number to the left side, add some number to the right side. How do we find that number? And why is it called completing the square? So most textbooks give you a recipe, say first do this, then do this, then do this, then do this, but I'd like you to see why it works. Our goal is always to try to understand why. So we're going to complete the square, so let's draw a square. So I need the same thing on the width and the height. So this is a multiplication box I like to use. I want everything in this box to represent x squared plus 3x. So x squared will go here. That's fine. But the 3x I have to split in two pieces. The x term gets split into this piece and this piece. So what is 1/2 of 3x? Well, 1.5x. Or half of 3x, 1/2 times 3x is 3x over 2. So we put a 3x over 2, or 3/2 x in this box, and a 3/2 x in this box. My model works off the idea that length times width is area. So if the area is x squared, the length is x, and the width is x. And you'll see how this will work, right? If the width is x and the length is positive 3/2, then the area is positive 3/2 x. Same thing here, positive 3/2 times x, positive 3/2 x. So again, using our area metaphor, one dimension times the other dimension gives us the area. 3/2 times x is 3/2 x times x is x squared, x times 3/2 is 3/2 x. Now, these three boxes are the same as x squared plus 3x. If you don't believe that, 3/2 x plus 3/2 x, 6/2 x is 3x. So these three boxes total the same thing as what's on the left side. But I want to add the same number to both sides. I have to complete the square. I have a missing piece here. Remember, length times width. The length is positive 3/2, the width is positive 3/2. If I multiply those together, I get 9/4. So by putting 9/4 here, now I have a perfect square. The width is x plus 3/2, the height is x plus 3/2, the length and the width, height and width, whatever you want to call them, are the same. So this rectangle is a square. That plus 9/4 will get added to both sides. Plus 9/4 on the left, plus 9/4 on the right. Now what does that left side represent? Again, x squared plus 3x plus 9/4 are these four boxes all together. But these four boxes are the same as x plus 3/2 times x plus 3/2. So x plus 3/2 times x plus 3/2 is the same as x plus 3/2 quantity squared. 1/2 is 2/4 plus 9/4 is 11/4. So again, left-hand side, x squared plus 3x plus 9/4, these four boxes, x plus 3/2 times x plus 3/2, x plus 3/2 squared equals 11/4. What's next? Take the square root of both sides. Remember though, when you take the square root of both sides, you must put in a plus or minus. So the square root of the left-hand side equals plus or minus the square root of the right-hand side. So the left-hand side will just be x plus 3/2. The right-hand side plus or minus square root of 11 over square root of 4. Square root of 4 is, of course, 2. So we get x plus 3/2 is plus or minus the square root of 11 over 2. Let's add negative 3/2 to both sides. And you'll notice we have x is negative 3/2 plus or minus the square root of 11 over 2, which is actually two answers. Negative 3/2 minus root 11 over 2, and negative 3/2 plus root 11 over 2. I like to write the final answers in set notation. So there you see negative 3/2 minus root 11 over 2, and negative 3/2 plus root 11 over 2. So that is our process. Let's rebuild it one more time from the beginning, a little quicker this time in terms of what's involved. I need the first coefficient to be 1, so divide everything by 2. I need the x's on the left. I need that number on the right. Add 1/2 to both sides. Now I need to figure out what I add to both sides to complete the square. There's the square. There's the x squared, which is x times x. Split the 3x in half. 3/2 x, 3/2 x. Length, width are both x for x squared. One is 3/2, one is x for 3/2 x. To complete the square, 3/2 times 3/2 is 9/4, and we add that to both sides. Now the shortcut strategy that textbooks will give you is take half of the x term. Half of the x term is 3/2. Square the 3/2 to get 9/4 and add that to both sides. I'd like you to know why. Looking at this square shows you how you indeed did construct a square with the same width and height by adding 9/4. So what we have here is x squared plus 3x plus 9/4, these four boxes. X plus 3/2 times x plus 3/2, which is x plus 3/2 squared, is 11/4. Square root, don't forget the plus or minus. So we get x plus 3/2 is plus or minus root 11 over 2. Add negative 3/2 to both sides. Negative 3/2 plus or minus root 11 over 2. Write your answer in set form. So that's the process. Let's try it again with another example. 3x squared plus 5x plus 1 is 0. What's the first thing we have to do here? First thing we have to do, divide everything by the leading coefficient, divide by 3. What does this become? X squared plus 5x over 3 plus 1/3 is 0. Okay. Now we have the 1/3 here. The 1/3 needs to be on the right side. How do I do that? What's my process for doing that? Let's add negative 1/3 to both sides. And now I need to complete the square. I need to add something to both sides. So take a minute, pause this video, and see if you can fill in these first 3 pieces. See if you can fill in these first 3 pieces and see what you get there. Remember, these three pieces have to be the same as x squared plus 5x over 3. So what will those 3 pieces be? First piece, x squared goes here. The outside numbers, the width and the height, x times x, fine. 5/3 x split in half to be in these 2 boxes. What's 1/2 of 5/3? That, of course, is 5/6. So 1/2 of 5x over 3 is 5x over 6. So those are the 3 boxes you need that add up to these 2 elements, x squared plus 5x over 3. Now, take a minute and figure out what's going to go on the outside of this. We've got x squared plus 5x over 6 plus 5x over 6. What are the numbers that are going to go on the outside? Take a few seconds to think about that. Remember, the width times the height equals the area equals the number that's in the box. What do we have? X times x is x squared. That's pretty obvious. So x times what is plus 5x over 6? X times what is plus 5x over 6? In each case, it is plus 5/6. Again, yes. 5/6 times x is 5x over 6. 5/6 times x is 5x over 6. Now, I have one last cell. We have to multiply these things together. 5/6 times 5/6 is 25/36. And that is what I have to add to both sides. Add 25/36 here, add 25/36 here. So these three pieces, x squared, 5x over 3, 25/36, are the same as these four boxes. But these four boxes are the same as x plus 5/6 times x plus 5/6. What is x plus 5/6 times x plus 5/6? That, of course, is x plus 5/6 squared equals the right-hand side. And what is that? That's negative 12/36 plus 25/36 is 13/36. We'll take the square root of both sides, but don't forget, when you take the square root of both sides, you need to put in a plus or minus. So we're going to get x plus 5/6 is plus or minus root 13 over 6. Adding negative 5/6 to both sides, we get x is negative 5/6 plus or minus root 13 over 6, which we write in set form. Let's finish up with one last problem. 5x squared minus 2x minus 4 is 0. Divide by the leading term, divide by 5. So we get x squared minus 2x over 5 minus 4/5 is 0. Move the 4/5 to the right side. X squared minus 2x over 5 equals 4/5. Add something to both sides to complete the square. Think about what's going to go in the box. So I put x squared here for you. These two boxes add up to negative 2x over 5. I hope it's obvious that each one will be negative 1x over 5. Width times height is area. X times negative 1/5, negative 1/5 x. X times negative 1/5, negative 1/5 x. To complete the square, we're going to multiply what? Negative 1/5 times negative 1/5, which is positive 1/25. And we'll add that to both sides. Positive 1/25 here, positive 1/25 there. These three pieces, x squared minus 2x over 5 plus 1/25, are the same as these four, x squared minus a fifth x minus a fifth x plus a 25th. But that is the same as x minus a fifth times x minus a fifth. X minus a fifth times x minus a fifth is x minus a fifth squared. 4/5 plus 1/25, that's 20/25 plus 1/25 is 21/25. Square root of both sides. Do not forget to take the plus or minus. So square root that side equals plus or minus square root that side. So we have x minus a fifth is plus or minus root 21 over root 25, but root 25 is just 5. Then I can add 1/5 to both sides. So we'll get x is 1/5 plus or minus root 21 over 5. How do I like to finish this? I like to go ahead and write the two answers in set builder form. So 1/5 minus root 21 over 5 and 1/5 plus root 21 over 5. And that will conclude this lesson.